Hello everyone, and welcome to this webcast about Apache Kafka on AWS. Apache Kafka is one of the most popular open source projects for building messaging and streaming applications. Kafka takes data from various sources, makes it available to different applications, and therefore helps to eliminate daily batch jobs. Kafka also plays an important role for change data capture, CDC, and in the world of microservices. This presentation gives an overview of the new Amazon Managed Streaming for Kafka service, short Amazon MSK. Based on knowledge gained from several Apache Kafka implementation projects, I will explain some of the technical underpinnings first. So you will learn about brokers, about topics, and Zookeeper. Then I will explain what makes Kafka special. We will analyze major pain points in running Kafka on premises. We will have a deep look into MSK and critically analyze how Kafka differs from Kinesis. And finally, we will conclude why the cloud is the best way to use Apache Kafka. My name is Munz. I'm a technical evangelist working for AWS. My background is in software architecture, and you can catch me on Twitter. That's easiest. Let's talk about streaming data first. If we mention streaming data, what we mean is continuously generated small size events that come with a low latency requirement. So Kafka started as open source at LinkedIn. They were trying to build a system that is suitable for web clickstream analysis. If you wonder why it can be so hard to deal with small-sized events, let's take the following into calculation. LinkedIn published a blog like 4 years ago. In this blog, they described that the total amount of events produced per day is larger than all the data they have stored in their relational databases. IoT sensors play another important role in the generation of data. Actually, there is a study out that says machine data will make up to 40% of our digital universe by next year in 2020. Note that there is a big risk of dark data. Dark data is data that is produced but never used or never analyzed. So it's very easy to imagine that a lot of this machine-generated data can become dark data. Also, while you're listening to this webcast, there will be web servers running, there will be databases running, and they're all generating application logs. So that's another great example of data that is continuously produced and that has to be transported and analyzed somehow. Now, why do we care so much about fresh data? If we look at this diagram that comes from Forrester Research, and you focus on the right-hand side of this diagram, you see historical data. That's data that we used to burn on CD-ROMs that today you might want to store on AWS Glacier. And it's data that becomes more factual knowledge, historical data. If you move to the left-hand side of this diagram, we get to more actionable data. Data that has an age of a few seconds only. Data that is very interesting. Now imagine you have a real-time data analysis with a monitoring that tells you that like 19 of your 20 machines are in a critical state and shutting down. You can action on this. You can react on this. Now imagine you feed the same data into a machine learning model that is even able to predict what is going to happen with your machines. Maybe based on the sound that they make, you can predict that some of those machines are going to break soon. Then you're on the very left-hand side of this diagram. You work with time-critical data that allows you to take decisions. And that's the most valuable data that we have these days. This is why streaming data with low latency requirements is so important. So let's look at modern architectures. It all actually started like this at LinkedIn. This is one of the original diagrams that was posted from LinkedIn. This is the situation they had to deal with. So a lot of systems were interconnected in a point-to-point way. If you have n different systems, you have like n squared number of interconnections. And so the first reason why to introduce Kafka was to get rid of this complexity, to reduce the complexity, to go from a n squared complexity to a linear number of complexity. If you look at this diagram and you count the connections from the unified log, which is basically Kafka, it's a linear number of connections to all the systems surrounding it. Now, the second reason is decoupling. Instead of one system talking directly to another system, now one system is talking to the thing in the middle, which is called middle layer, which is Kafka in our case. It's a unified log. And you send messages or events to that log, and then other systems read from this log. So it's decoupled. Instead of synchronous communications, for sure you have asynchronous communications. And even if the destination system is not available, it can pick up the message later and read the message and process the message. Now, obviously, it's important that the thing in the middle, that Kafka, is highly available. Otherwise, it wouldn't work. So remember, it's two things. It's reduced complexity and it's decoupling that is interesting for us. Also, we can make use of Kafka in the world of microservices. In the world of microservices, there is a different number of techniques that are interesting, that might be beneficial to your project, and it's up to you to decide if this really makes sense or not. I want to introduce you quickly to 3 approaches, and they all show that there is a much more modern twist to Apache Kafka in the world of microservices. So the first one is called event sourcing. This is where you do not just keep the final state of something, but you keep a time-ordered processable sequence of events that you can reprocess to recreate the state. Now imagine you had to do the same thing with a relational database. This is possible, but it's much more challenging. It's much more complicated. The second one is called CQRS, which stands for Command Query Responsibility Segregation. Now, this is a way to improve the throughput for databases. This is because you separate the reads, which are the queries, from the writes, which are the command operations. And because you separate them, you can optimize them in different ways. Actually, very often event sourcing and CQRS work together. The third thing I want to talk about is choreography. It's actually choreography versus orchestration. Now, choreography is what you get if you have an event that triggers an action. This is what we call choreography. And orchestration is what we get if we have a centralized workflow. Like just imagine you go to Symphony Hall where there's a conductor in the front. This is like a synonym, like a metaphor for a centralized workflow, whereas a ballet where there is no conductor in front is very similar to choreography, where systems just interact. Those ballet dancers, they don't bump into each other. And in the same way, those events, they just trigger actions, and it's super easy to extend such an action by another action that can be triggered by the same event because there is no centralized workflow. Now, the last thing I want to point out is a very interesting architecture that was done by the New York Times. It's using Kafka as a data store, actually as a data store where the data in the store never expires. So there is a number of producer systems that produce digital content, and all the content that is produced by those systems is stored in a single Kafka topic. And there is obviously also a number of consumer systems that read the content. And Kafka in this way is storing the messages. It's almost acting as a database because the retention, the timeout when those messages would expire is set to -1. That means the messages are kept forever. So this way, the New York Times is storing all articles since 1851. They have multiple content producers and consumers, but they work with a single Kafka topic. And new consumers can be added without any change in the system. So let's keep this in mind. I wouldn't say this is the most typical implementation for Kafka, but that's one of the possible solutions. And let's keep this in mind. It becomes handy if we compare Kafka to other systems later on in this presentation. And now I think it's time to familiarize ourselves a little bit more with the inner workings of Kafka. So let's look into Kafka. Kafka in its core is a commit log. A log is just another word for a stream, and logs are the heart of stream processing. The interesting thing is that if you are a producer and if you append to the log, that means if you send a message or an event to the log, it's appended at the end. It's appended as a new event. It doesn't really matter if you have 1 gigabyte already in this log, or maybe 100 gigabyte, or maybe 500 gigabyte, because the append function sending messages from a producer to the log is always having a constant overhead. So it doesn't really matter how much data is already stored in a log. It's not getting more costly for a producer to send data to such a log. On the other side, what you see on the left-hand side of these diagrams, a consumer is reading from the same log. Now, different consumers can read from different positions in this log. The interesting thing is, and that's a very small semantic difference to other messaging systems that you might know, such as SQS or JMS or IBM MQ series. So the interesting small difference is that such a consumer is reading a message, but the message is still in the log. It's not taken out from the log if you read it. And this is also why consumers can reread the same message. Actually, if you have a consumer A or B that fails and that needs to reread the same messages from a whole day, it can just do this. It can kind of position itself to any position, to any message offset, and then reread the messages. Now, the messages in the log, they expire after a while. The default expiry is 7 days, but you can set this to unlimited, basically as we have seen in this New York Times example. And what you see here, this is the view for one single broker. So it's one broker, one log. There's actually a small book out with which I put there on the top right corner. It's called I Heart Logs. It's a very interesting read. It's a bit old now, but I still recommend it because it goes back to the basics of Apache Kafka. When I told you it's a commit log, I was simplifying a little bit. Actually, it's a distributed, partitioned, replicated commit log. If we replicate a single log, we replicate it across brokers. The brokers are the instances, the different machines. So the brokers run on different separate machines, and they work together in a cluster. This is how we make those brokers work together. If you have a topic, this topic is partitioned. It's split across a number of brokers. Now, in my example, I have a topic A, which is split across broker 1, 2, and 3. So this is why we have a partition 1, 2, and 3 from topic A. Now, if you have a producer, the producer is either writing with a key, and then what happens is the key is used and it's hashed, and the hash of the key determines the partition where it's written to. And if you do it this way, it's actually very recommendable that you use a key like a session ID. So the session ID stays the same for a web session, and then all the data for one particular producer ends up on the same partition. And that's helpful because you have a guaranteed order of messages within a single partition. Now, if you don't provide a key, what happens is the data is load balanced across all the available partitions. This is not all that you need to know. Actually, there is state saved in the Kafka system. And it's not saved in Kafka itself. It's actually saved in Zookeeper, which is a different open source project. Now, for Zookeeper, you need to start up the Zookeeper processes. Because it's storing state, it has to be highly available. This already tells you that you need more than one process. Actually, you shouldn't use two processes because what could happen is a network split. And if you have a network split, what happens is the zookeepers that remain on one side of the network, they determine if they have the majority of the instances. So if it's configured for 3, as in this diagram, and you have a network split and one side finds out that it has 2 Zookeeper processes, it already knows that it has the majority, and those 2 Zookeeper processes, they continue to work. Whereas on the other side of such a network split, the single Zookeeper process realizes that it's in the minority and it's going to shut down for consistency reasons. This is also the reason why you should have an odd number of Zookeeper processes, so not like 4 or 6 or 8, but something like 3 or 5. Now, there is more to it. You also need to understand about replication. Now, remember when I told you about those partitions? We use partitions to spread the data across brokers, and we do this to increase the throughput. So the partitions are there for more throughput and for more concurrency. Now, replication is when we take the content of one partition and we replicate it to a replica that is living on another broker. So replication is not there to increase the throughput, but replication is there to increase the availability. Imagine partition 1 from topic A goes down, then we will still have a copy of the data in the replica that lives on broker 2. So remember, partitioning is for increasing the throughput and replication is for increasing the availability of the data. So you all see that this is quite a bit challenging to configure right. Now, as I told you in the introduction, I was doing like 2 large-scale Kafka projects on premises. And what we realized in those projects is that basically it took us a couple of days for the coding, for the development, for integrating Kafka into some other system, sending messages to Kafka, and then reading messages from those Kafka brokers again. So that's basically a question of a couple of days. But then for the same projects, we spent several weeks, to decide how Kafka should be installed, like literally how to install Kafka, what parameters to use, what's the number of topics, what's the number of replications, how to hand this over to the operations team, how to train the operations team, how to understand about patching, how to understand about upgrading. Now, basically all these operational challenges, they're much, much bigger in reality than just getting Kafka up and running on a single laptop and finishing your development. So it's difficult to set up. It's kind of hard to achieve high availability unless you really know really well what you're doing. There is no shiny, glitzy console that comes with Kafka. There is monitoring data, there is configuration data that you can retrieve, but it's not a graphical web-based console. It can be tricky to scale. And if you do it yourself, it's also kind of questionable how you will integrate this with the remaining AWS services. So basically, there is larger operational challenges than that most people assume when they start working with Kafka. And we were thinking about, what we can do for you. So the question is, how can you run Apache Kafka on AWS? Okay, let's start with the easy approach that kind of makes sense, that is easily understandable to everyone. You can just manage Kafka yourself and install Kafka and operate Kafka on top of EC2. If you do this, you still run into the same operational challenges that I just described. Then the second approach is a very technical approach. What you could do is you could run Kafka on top of Kubernetes. Kubernetes is a container orchestration system that is very popular these days. It's open source, same as Kafka. So one question is, why shouldn't you just run Kafka on top of Kubernetes? Actually, it's possible to do this with a so-called Kubernetes operator. That means you extend the Kubernetes system. You even extend the Kubernetes command line, the kubectl tool, by including Kafka commands. So you can use the Kubernetes command line to create and start and manage Kafka clusters. And that sounds like a very technical, very sophisticated way of doing this. Now, if you have the knowledge, there is no reason why you should not do this. But let me give you a small warning with this. If things are working, it's probably a nice approach. But as soon as you run into trouble, in my opinion, like the complexity of Kubernetes and the complexity of Kafka, they're basically almost multiplying with this approach. So do this only if you really know what you're doing and if you really have strong reasons to run Kafka on top of Kubernetes. And the easiest approach that we can offer today is using managed streaming for Apache Kafka. That's this presentation. That is what this presentation is about, because it's a managed service. And with this managed service, we solve all the operational overhead and we take all those problems away from you. So let's look into MSK. So why should you use MSK? Well, you should use it because we do the heavy lifting for you. We run Apache Kafka for you. And this also means that we will offer you new Kafka versions when they become available, so you can upgrade. You can monitor your Kafka clusters and brokers and topics using CloudWatch, and you can easily expand your disk space. Let's start looking into the Zookeeper processes. Remember, these are the processes that keep the configuration state of Kafka. Now the Zookeeper is gone. Well, it's actually not really gone, but it's hidden. It's still running under the hood. We set it up highly available. So we take care of, the number of instances, where to place the instances. We back them up, we replace them if they break. And the good thing is there is no additional cost for you. So in MSK, you don't pay for the Zookeeper processes. And come on, if you think about it, this is as good as it gets. No, you don't see it, you don't pay for it, we configure it for you automatically. So stop worrying about the Zookeeper processes if you work with MSK. What we do is, if you create a cluster, we give you the Zookeeper endpoint so you can connect to it. To create, manage, or list the MSK cluster, you can use the AWS console, or you can use the command line. Okay, so to get started with MSK is super easy. You just go to Services, MSK, then click on Create New Cluster. Give the cluster a name like Kafka. Choose a VPC. I'll go for 2.1 version number. My first availability zone is here in Frankfurt. Pick a subnet. Pick the second one. Matching subnet. Third one. That's it. Let's have 2 brokers per availability zone, which will give us a total of 6 brokers. You can put a tag if you want. You can actually increase the storage here or go for 1,000 gigabyte per broker. Then we can encrypt. We can encrypt the data in transit within the cluster, enable encryption within the cluster. I'm fine with that. Between the clients and the brokers, only TLS, both. Only plain text. Let's do both. I want to have the option. Then let's encrypt data at rest. It could be AWS managed CMK, or it could be customer managed CMK. I don't want to manage the key, not for this demo, so I use AWS managed CMK. Authentication, for this demo, I don't care. Monitoring, it could be basic, it could be per broker level, or it could be per topic level monitoring. So I'll want the finest. I'll pick enhanced topic level monitoring. Under advanced setting, you can choose customize settings, and then you can select the broker instance sizes. Let's go for a bigger one, and then I can select the security group. I'll pick the default one. Actually, I'll pick this one. That's fine. And then I click on create cluster. Now this is going to take a couple of minutes. I will pause the video and I come back to you once the cluster is provisioned. Now the cluster is active. You see that I had another cluster. I do have another cluster that I want to get rid of just to tidy up and to reduce costs also. So this is being deleted now, and this is the one that I created. If I click on the cluster, you see all the details like the cluster ARN, the brokers, 2 per availability zones, the networking. You see status, creation time, and the version. The monitoring level, where I picked the detailed one, the topic per broker monitoring. We do have encryption of the data in transit and encryption of the data in rest. That's the key in KMS, and I took the default storage. Yeah, and remember that silly tag here. Cool. Now, the most important thing is getting the client information to be able to connect to the cluster. Now, this is the client configuration for plain text communication for the Bootstrap service and also for the Zookeeper Connect. I'll copy those. Now, what I have is a EC2 instance that is running in the same VPC, so I can easily access my Kafka cluster. I'm not using SSH here to connect to it, but I want to use the System Manager. And in the System Manager, I go to Session Manager. In the Session Manager, I want to start a new session. Actually, those instances, they have a special role, so I can access them with the System Manager and start a new session. I'll pick this one. They're both the same. Start a new session. And that's the EC2 instance that is running. Okay, let's create a topic first of all. I want to name this Live FM, and I am happy with 2 partitions. Let's keep a replication factor of 3, and let's put the Bootstrap service here. Okay, let's correct this. And there we go. We have a new topic. Okay, then let's send some messages to this topic. That was Live FM. Okay, that's it. So those messages are in the Kafka topic, in the replicated Kafka topic right now. So let's try and read those messages. Basically what I want is the same topic, those bootstrap servers. So I'll give it a bootstrap. And I tell it to read from the beginning. And here we go. You see the messages. Isn't that perfect? Okay, and let's just rerun the same command again. You see it's retrieving the same messages again. Now I'll keep this running. There is no new messages at the moment. For the following example, I want to use a different tool. It's called Kafka Cat. Kafka Cat. And I want to list everything that we know for the brokers. And it's actually giving me a lot of detailed information. So I have 6 brokers and I have 2 topics. One is a topic that is used internally. It's the consumer offsets. And one is the topic that I created. Remember, 2 partitions, partition 0, partition 1, with the replicas. And now I want to send data. I'll keep the broker list. I add the topic. You see it's received on the other side. And I can also replace this consumer with Kafka Cat. Give it a topic name and say consume. And you see it's consuming. Fine, that looks good. Okay, so Kafka Cat is an additional tool. It's not part of the Kafka download. It's an additional tool that may or may not be part of your Linux distribution. If it's not part of your Linux distribution, you can easily install it using apt-get. It's a little bit more difficult if you have Yum as a package manager, and it's super easy if you're running on a Mac. You can just do a brew install Kafka Cat, and that will give you this tool. Now, this tool, I must say I like it. It's quite interesting because it doesn't depend on Java, so you have no prerequisites, and it also doesn't depend on having a local download from Apache Kafka. So once you build it, once you install it, you can just use it. And the syntax is maybe slightly easier. So have a look at this yourself. You can easily get information about brokers and topics. You can write as a producer with -p, and you can read from a topic with -c. That means you're a consumer. So if you're interested, have a look. At the end of this presentation, I will give you a link to a posting, and in this posting I'm going to list a whole number of different resources that might be useful if you plan to work with Kafka. And in the list of these resources, I will also give you a link on how to install this on Amazon Linux, where you typically work with the Yum package manager. So far for Kafka Cat. Let's go back. So coming back to the slides, you've seen a lot already demoed live. I showed you how to define security, that we have data that is always encrypted in rest and that it can be encrypted in transit. You choose if you want to use AWS managed keys or you want to manage the keys yourself. You have seen the scaling while I created a cluster, but anytime while the cluster is running, you can also change the scaling, increase the amount of disk space that is available for the brokers to write the log files. Let me show you this. That's my Kafka cluster. This is the general information, the encryption that we have just seen. And here we get to the storage. Now, the storage I can increase. Let's say we want to have 1200. And it's then updating the EBS storage that is available for the Kafka cluster. This takes a minute, so we're not going to wait for this. The next topic is that you can create a Kafka cluster also using CloudFormation. You can do CloudFormation or CDK with TypeScript, for example, but here in this little demo, I will show you CloudFormation. The documentation is available here. This is also where you get examples. Now I built another cluster, this one here, using the following template, which is actually exactly the one that you have seen on the PowerPoint slide. So this is maybe one of the easiest templates that you can use to create an MSK cluster. Obviously, it's essential that MSK is supported by CloudFormation if you want to implement a infrastructure as code approach. Remember when we discussed the operational challenges when running Kafka yourself? Now, one of those challenges was monitoring. And actually, Kafka, if you install it out of the box, is not integrated with a graphical or console-based monitoring tool that would easily visualize any values. This is where MSK shines because we can display important Kafka values. Actually, there's different monitoring levels that we can set in MSK. The default one is the free one. Then we have per broker and we have per topic per broker. And you'll all find them under this link. So again, the different monitoring levels. Then the first one, the default one. You see that you already get information about things like Zookeeper session state. You get a global partition count. You get things like free swap or the memory that is used by the Kafka broker, CPU system, CPU idle times, and all this. Now, if I scroll down, we get to per broker level monitoring, which gives you even more insight into your brokers. And then if I further scroll down, you see the per topic, per broker level monitoring. That gives you information as detailed as bytes in or messages in or fetch message conversion per second. All right, so let's see this in live. To do so, I go to CloudWatch. Now in CloudWatch, what we can do is we can directly drill down to the metrics and go to Kafka. And then you see different areas of metrics that you could select. Or to get something a little bit more visual, I already prepared a small dashboard for you. It's called Kafka Dashboard. And if I click on it, you see that I have a very low Zookeeper request latency, which is about 2 milliseconds. There are 0 petitions offline. And these are the network receive error counts for all 6 brokers. They are 0. Now, let's extend this just to show you how this is working. Let's add another widget. And the widget that I want is a stacked area widget. I say configure. And Now here in this search box, I can specify what I really want to add to the widget. So my cluster is called Kafka Live, and I want to narrow it down to Kafka Live. And then I'm interested in CPU values. And looking at this, I will see things like system CPU, CPU idle. I actually like to see the user CPU used. So I add this to search, and then the search narrows down to exactly my 6 brokers. I take all of them. I add them to the diagram, and then I create a widget which shows up here. Isn't that easy and very useful? I save the dashboard, so I can come back anytime, use the dashboard to monitor my Kafka cluster and the brokers and the topics. There's another interesting topic. Let's talk about custom configuration options for MSK. When you create an MSK cluster without specifying a custom MSK configuration, Amazon MSK creates and uses default configurations with the values shown in this table. For properties that aren't in the table, MSK uses the defaults that come with Apache Kafka, which obviously makes a lot of sense. Now, you can create, list, and delete custom configurations. For example, you can use the AWS Kafka create configuration, CLI, and then use it with the AWS Kafka create cluster CLI. Use this custom configuration that you created to create a new cluster. Or you can use obviously the same for CloudFormation. You see these custom configurations. And here is where we show you how to create custom configurations. These are the available configuration properties: default, Amazon MSK configuration, and MSK configuration operations. Now, the pricing is also very interesting. It's interesting because you don't pay for the number of topics that you create. You also don't pay for the replication traffic or the Zookeepers. What you pay for is the brokers. Like a Kafka M5 large broker costs you like $21 per hour. And you pay for the storage, like the gigabyte per month. It's like $10 per gigabyte per month. And this also brings us to the next topic, which is, what should you use? Amazon Kinesis or managed streaming for Kafka? It's important to note that we have Amazon Kinesis services. It's actually more than one service. It's 4 services. It's a family of 4 services. One is Kinesis video streams that enables customers to stream video from millions of devices and play back video in live or on-demand mode. The second one is the core of data streaming. It's called Kinesis Data Streams. It allows you to ingest and store data streams for processing without the maintenance overhead of a streaming data platform. Then we have Kinesis Data Firehouse. Data Firehouse gives you an easy and efficient way to load data streams into AWS data stores, like S3, like Redshift, like Elasticsearch, and Splunk. So basically, Kinesis Data Firehouse is a managed consumer and writes to AWS data stores. And then we have Kinesis Data Analytics that allows you to analyze streaming data in a serverless way with SQL or Java. Trying to compare Amazon Kinesis data streams with MSK from a higher level, it looks very, very similar. So for Kinesis data streams, we have streams with shards. The shards basically define the throughput. And for Amazon MSK, we have topics with partitions. So this diagram from this level of abstraction doesn't help us a lot. We have to dig in deeper. Looking again at Amazon Kinesis data streams, it comes with an AWS API. So we build it from ground up. The interesting thing is it gives you a throughput provisioning model. And this throughput provisioning model is very interesting. And it's actually incredibly beautiful because the throughput that you need to have, you simply define it by configuring a certain amount of shards. One shard in one stream gives you 1 megabyte for the producers. So you can produce 1 megabyte per second of data or 1,000 put records of data. And you can consume 2 megabytes of data. It's actually the consuming bandwidth is a little bit higher because those consumers, they could fall behind and then you need to read more data. And all this is per shard for all the consumers. It scales seamlessly. We build it like this. It has a retention time of 1 day. You can set it to maximum 7 days. But this also means you cannot build something like the New York Times example that I gave you, where a Kafka topic doubles as a database. But on the other hand, you get deep AWS integration with all the monitoring, with everything. Looking at Kafka, Kafka is different. It's open source. So it comes with an open source API. But for MSK, we obviously give you an API to create a cluster. The important thing is it is a cluster provisioning model. So you don't define the throughput, you create a cluster. But in this cluster, you can have thousands or tens or hundreds of thousands of topics because you don't pay per topic. That's very interesting. So if you have a model where you need a lot of topics, maybe to ingest data from different sources, but you don't use those topics all the time, it's possible to have thousands or even tens of thousands of topics in a single cluster, and you don't pay for those topics. The throughput is not guaranteed in this case, so it's not like Kinesis data streams. The throughput at the end is obviously defined on what instance sizes for the brokers you're going to use. So it's a cluster provisioning model, and it's not a throughput provisioning model like Kinesis. And that's a major difference that you should take away from this presentation. Scaling is not that seamlessly. That's a longer story. I don't want to go into details here. Scaling clients that consume from a Kafka topic, please look that up. Then the retention could be unlimited. The default is 7 days. And people simply love it because it comes with so many strong third-party tools that you can use. So overall, there is a difference between Kinesis data streams and Apache Kafka. If you're the architect, it's your job to decide which one is more suitable. It's not that one is better than the other one, but you need to decide which one is the more suitable solution in your use case. Now, to conclude, remember, streaming data and streaming is about actionable data. You want to have access to this data as quickly as possible. You want to process it in real time. Kafka is an open source, very versatile, and a super popular streaming platform. And we are more than happy to offer you this as a managed service with Amazon MSK. Managed streaming for Kafka MSK basically means we run Apache Kafka for you. So we did the heavy lifting, you create a cluster, and then you use your standard clients because we provide standard upstream Apache Kafka as a managed service. Now go and build something awesome with MSK or Kinesis. To simplify your life a little bit, I created a list of resources with links and documents and videos. It also includes the Kafka Cut tool and how to install it on Amazon Linux. To get to those resources, just use the QR code or use the link underneath. With this, I want to say thank you. Thank you for listening. If you want to contact me, use Twitter or talk to me on LinkedIn. Feel free to subscribe to my blog. If you are interested in these slides, you can find them on speakerdeck.com/fmunz.